Oh, here comes Corey. Oh my gosh. Okay. So today's lesson is on dilations is when you make an image bigger or smaller. And this first example shows us two methods on how to dilate an image. I'm going to give you guys a third method that you'll be using like on a coordinate plane. But this really just shows you like the properties behind a dilation. So method one is called the ratio method. In order to dilate a shape, you need two things. You need a scale factor. Well, three things. You need a scale factor, a center of dilation, and you need the pre-image, the thing that you're dilating. So if you're using the ratio method and you're dilating a shape, you put your center, find your center, find your pre-image, right? This is our pre-image because it doesn't have any tick marks. And then you use the scale factor to draw the image. So our scale factor is 1/2. So that means our image is going to be half the size of our pre-image. Okay. And so because our center is back here, the image is going to retract back towards the center. Okay. You see these lines that they've drawn from the center to the pre-image. Okay. The image is going to lie in between those two points because it's gotten smaller. So you see the lines get closer and closer together as they get back to the center. So all of these, if we were to dilate something and make it smaller, it would lie in between the center and the pre-image. Okay, so what they did was they drew the center and then point A, and then they made a point halfway between P and A. So that point would be A prime. Okay. And if you look here, you see it looks like it's right in the middle between P and A. And then they did the same for B and C. B prime is halfway between P and B. C prime is halfway between P and C. Okay. So that's the ratio method. And if you look at the side lengths too, the side lengths of the image are half the length of the pre-image. Okay, like that. Any questions on that? No? All right, I'll check back there in a little while. Oh, wait, sorry. Okay, the second method is called the parallel method. So when you dilate shapes, the sides of the shapes remain parallel, or they become parallel lines. So you see, here's our pre-image WXYZ, and we're dilating it with a scale factor of 2 and a center of dilation at Q. Okay, so Q, see where Q is inside the shape. So that causes the pre-image to expand outwards. Um, and since the scale factor was 2, that means it's going to be bigger. So that's why it's expanding outwards and the lines are parallel to the original. But the same thing holds true for the side lengths. W prime X prime is twice as big as WX. Same for all of the other sides. Okay. Um, They still took the center and drew lines from the center to the pre-image point, and then you take that length, whatever that length would be. Let's say this length was 3. Okay, we will multiply it by the scale factor, which is 2. Okay, 2 times 3 is 6. So that means the distance from the center to the image point is going to be 6. Okay, twice as big as the distance from the center to the pre-image point. Okay, so we're not going to do this, try it. I'm going to go to this concept here. And I'm going to write some things down. Move this out of the way. All right, so a dilation is a transformation that has center of dilation C and scale factor N, where N is greater than 0 with the following properties. sorry, y'all. Okay, so the notation is a capital D with a subscript of N and C. N represents the scale factor that tells us how big or how small the shape is going to get. N is always positive, okay? Um, the C stands for center, and that's the center dilation. The center dilation can be anywhere. It can be in front, behind, on the shape. It can be in the middle of the shape, like we saw in one of our examples. And I'll just go ahead and skip to this part right here. If N, which is the scale factor, if N is greater than 1, that means your shape is going to get bigger. If N is between 0 and 1, like a fraction, like 1/2, like we saw earlier, or a decimal, if it's between 0 and 1, then it's going to be a reduction, so that's going to get smaller. Okay. These other points, this first point R maps to R prime in such a way that R prime is on CR and CR prime equals N times CR. So we look at this example right here, okay? All it's saying is that when you dilate a shape, if you took a line and connected it from the center, our center is C in this example, to the pre-image, which would be point R. You see this line right here? When you dilate the shape, the image point is going to follow that same line. Okay, and I could dilate it bigger and bigger. It's always going to just travel along that same line. Okay, same thing for all of the other points on the shape. So you can see with X too. You see from C to X, create that line there. When you dilate it, it's just going to keep following that line, and it's going to keep getting larger and larger as it goes out. Okay, the reverse is also true. If you were to do smaller, then it would follow that line, but just be getting smaller and smaller as it gets closer to the center. Okay, any questions about that? No? Okay. Oh. Each length in the image is n times the corresponding length in the pre-image. So like I was saying with the previous example, you take the pre-image and you can multiply it by the scale factor. So whatever the scale factor was here, let's say it was 2. It doesn't look like it's twice as big. Let's say it was 2. You take this pre-image, multiply its length by 2, and that would give you the length of the image. Okay. We just talked about this with the scale factor. And then all the angles stay the same when a shape is dilated, so that doesn't change. So that means the shape stays the same. It just gets bigger or smaller. And we talked about the notation already. Okay. Example 2. And then we're going to, this would be our last example. Any questions on example 1? All right, so example 2, analyzing dilation. So rectangle A prime, B prime, C prime, D prime is a dilation with center P of ABCD. How are the side lengths and angle measures of ABCD related to those of A prime, B prime, C prime, D prime? So here's our center. It's always important to know where your center is, just like with rotations, you have a center of rotation. For dilations, you have a center of dilation. So that is going to determine like if your shape is going to go out like this, or if it's going to like expand around the original shape like we saw in our previous example. That all comes from wherever your center is. Okay, so how are they related? What kind of shapes are these? Who can answer me? Somebody type it in or say it. What shape is this? Thank you. Okay. And then so all rectangles have the same angle measure. What's the angle measure? Yes, very good. I can't see who's saying that, but okay. Yes, thank you, ladies. So they both are still rectangles. So that means all their angle measures are still 90 degrees. So that reinforces the fact that the angle measures don't change. Okay. All right, now let's look at the side lengths. If we look at the side lengths of side length of AB, okay, you count 1, 2, 3, and then count the side lengths of the image A prime, B prime. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at BC. BC is 1, 2. B prime, C prime is 1, 2, 3, 4, 5, 6. Okay, and so since it's a rectangle, these other two sides are going to repeat what we already saw. So how do you think the side lengths are related? Like what do you think the scale factor is? What do those numbers have in common? 3 and 9, 2 and 6. I'm gonna call on somebody. I can still do random, even though y'all not in the classroom. I can still do. Let's see. Jada. How can I get from 3 to 9? What can I do to 3 to get 9? And what can I do to 2 to get 6? Right? And then multiply 2 times 3 to get 6. Really? Thank you. Very good. Yes, you got it. So that means the scale factor is 3. Okay. So the scale factor is 3. The image is 3 times as large as the pre-image. Okay, that also works with like the things that we were talking about earlier with the lines. If you connect the center to the pre-image, see here, the center is P. If I count from P to A, that's 1, 2. Okay, and then if I count from P to A prime, I got 1, 2, 3, 4, 5, 6. Still proportional by 3. Still multiplying by 3. Okay. All right. Okay, so this is just showing you why 3 is the scale factor, how they're all related by 3. 9 over 3 is 3. 6 over 2 is 3. And the same thing for the other two sides. So they're all proportional by a scale factor of 3. Okay. All right. We're going to do this. Try it. All right, so if you look at rectangle W prime, X prime, Y prime, Z prime is a dilation with center P of W, X, Y, Z. How are the side lengths and angle measures of the two figures related? First of all, Noah, can you tell me, do you think this is an enlargement or a reduction? Noah, you can type it in or you can unmute yourself. Alrighty. Is Nikayo on here? No. Yeah, I don't think so either, Josiah. Do you think, can you tell me, do you think it's gotten bigger or smaller? Right, yeah. So if you look at this dilation, would you say it's a enlargement or a reduction? Yes, yes, excellent. Very good. So that means our scale factor, do you think wait, I'm gonna ask someone else. Hold on. Well, we on. Let me see. Is chorus in here? Chorus. Do you